Hello everyone, the topic of my presentation is influence of persons' names on large language model implementations in daily life scenarios. This is what I want to explain today. And before the presentation, I need to introduce the 5 scenarios in my paper. The first one is paper cutting. Second one is tree climbing. Third one is river swimming. Fourth one is movie watching, and last one is drink and drive. Okay, let's go to the first part of my research introduction. Currently, the large language models such as GPT 3.5 and GPT-4 are being widely applied in the real-world tasks. And in this experiment, we attempted to manually aid the potentially dangerous events in the conversation and observe the changes of the large language model behavior. And in our experimental results show that large language models can easily change their decision in the daily life situations, even if small alternation to users' names are made. So I will introduce some related work. The first one is LLMs in the real-world environments. This model name is Palm-E. The largest version is Palm-E 562B with 562 billion parameters. Excels in visual language tasks, including purely robotic ones. And this model can help robots in the real-world environments. And for example, act to the comments are bring me the race chips from the drawer. Such actions include multiplying steps using large language models, as well as incorporating visual feedback from the robot's camera. And the next one is real-world simulation, DynaLAM. In the DynaLAM project, users can interact with small town composed of 25 agents using natural language. These agents use a large language model to generate the conversation answer behind them. And is the text names and the large language models, byte size 32. In this paper, authors evaluated the physical reality element of the generated games and find that only 2.1% of games accurately model the physical world. GPT-4 still has limitations in understanding the world and generating correct explicit word models. So for the time being, we found these systems not enough flexible to simulate dangerous situations. Therefore, we decided to experiment only with the text-based descriptions of daily life. Let's go to part of the experiment. The first step is in the experiment. We modified the prompt templates provided by the long-chain framework to tailor them to the specific context of our study. And this is the basic values, the game description, quest, character name, and the storyteller name. So the first is prompt template for creating character descriptions. And in this table is a prompt template for describing the family assistant robot. And the second step is performing simulation. Characters in the scenario will have conversations with the robot in turn. Their conversations will be recorded, and subsequent conversations will unfold based on the content of the previous conversations. And then we prepared 2 groups of the names I mentioned before. This is a cooperation about the frequencies of the exact matches of all names with Wikipedia search. We alternated by the ordinary family. First, we use the well-known family as the factors in the simulation. And the next, we use the ordinary family names in the simulation work. Then we reran the simulation with theme prompts and choices to acquire rankings of the solutions made by the large language model. And then we create a golden standard data. We recruit 5 volunteers on the internet to order the solutions in different scenarios according to their preference. Then we use technical called order count to decide the golden rule. With step 5, calculating difference between the runs. We calculate the Euclidean distance. We replace the 4 options A, B, C, D with 1, 2, 3, 4, and the similarity measurements between outputs for both groups and the golden data. At last, we have additional famous names experiment. We add 3 sets of the names to see other names from the similar effects. The first one is American basketball stars fan, LeBron James. The second one is famous football players families, Leo Messi, and the last one is former U.S. President Obama. So this is an experimental result. Euclideans between the human preferred action order and the model preferred action yields difference of 0.37 points on the average when the prompt contains the better known names. And because in the second scenario, the distance is the same, so we have the additional experiment. So in this scenario, the result of the previous experiment shows that distance between 2 groups of the names was same. So but we have the additional experiment. Also, the first one was perfect, but this overly perfect result occurred only once in all experiments. And the next 2 sides of the experiments were higher than before. We think that there is a still risk in using well-known names in the simulation work. So for the difference in the model with performance, we can see that in the face of potential danger, people usually want the robot to call the parents of the child to ensure the safety of the child. But when a famous daughter wants to go swimming in the small river, models prefer robots to go swimming in the river with the girl, while human volunteers choose calling parents as the most preferable action. This can mean that a model is influenced by the corpus interests about the behaviors towards the famous people. For example, you log posts about going to see a famous person. For the discussion part, we try to find the description automatically generated by the language model. If I want to ask who is LeBron James, the language model will give us the answer excellent, will introduce the excellent basketball skills. And for Leo Messi, the language model will give us accomplishments in the field of the football. At last, for Obama, the large language model said that he is a great leader. So when faced with the famous people's names, LLM may prefer solutions that are more suitable for the famous people rather than for the users with identical names. For example, if the user's name is Bill Gates, we usually think about the CEO of the Microsoft. And the large language model will have the same association. Hence, the successions given may not be suitable for the ordinary who accidentally shares this. At last, the conclusion, all research have identified a significant phenomenon wherein the name of users can impact the judgment made by the large language model-based agents. So at present, I think the best solution is to provide the detailed personal information when designing the agents. And this is our future work. We need to test other language models and come up with a method which could automatically insert a potential problematic utterance. And we plan to widen the similarity measurements also to explanations, which a given model generates after making a choice. Okay, thank you. Thank you for listening.